Hi, and welcome back to Python Deep Learning for Beginners. We're in the last chapter about moving forward with deep learning and AI. In this section, we're going to take a look at two different topics. Number one, comparing different deep learning frameworks and seeing how we should proceed now that we have the basics. And number two, exciting areas for upcoming research in the deep learning realm. Comparison of deep learning frameworks. In this video, we're going to take a look at three different deep learning frameworks. One is TensorFlow, which is the granddaddy of Keras. One is Keras, which we have already been very familiar with throughout this course. And the last one is PyTorch, which is an exciting new contestant in the deep learning framework category. Let's go in to look at it one by one. TensorFlow is created by Google to replace a framework called Theano, which is no longer under active development and support, so there's no need for us to care about that. TensorFlow is a framework that is written in Python over C and C++, and uses C and C++ mainly to speed up the calculations required in doing deep learning. As part of this, it leverages the NumPy framework for scientific computing and various data structures in scientific computing. It is slower than frameworks like CNTK and MXNet based on its architecture decisions, but it's very popular and has a large community of support around TensorFlow. It contains Keras as a submodule, so as we have mentioned earlier in the course, in the contributed modules section of TensorFlow, Keras is a member, so there's official support and synergies between knowing Keras and moving from Keras into TensorFlow. It also contains Eager as a submodule. What Eager allows you to do is eagerly execute computes in your dynamic computation graph. How you define your neural network, it allows you to execute ahead. And so that's one of the main differentiation points between TensorFlow and other frameworks. However, the deep learning community has been voicing its concerns about the fact that you have multiple ways of implementing the same neural network in TensorFlow, and that's kind of confusing and also very hard to manage, especially when you have teams of developers working on TensorFlow together. Everybody might have a different context, different understanding of how to do the same thing, and it makes it very difficult to understand one another. Another strong point of TensorFlow is that TensorFlow ships with TensorBoard for visualization, so it helps us a lot in terms of understanding how our models are ran, how the errors converge and evolve over time, and that's not something that, for example, PyTorch has. Keras is the main character of this course. As we said at earlier this course, it's a very easy to learn, very high level deep learning framework that allows us to leverage backends like TensorFlow. So it still allows you to leverage the same power offered by TensorFlow, but in a much simpler API. In fact, the API for Keras is inspired by Torch, which is another framework we're going to talk about later, as we can see when we get into some code examples later on in this video. We can see that Keras has a lot of commonalities shared with Torch. The benefit of Keras is it works with multiple backends, and it's very easy for us to start tinkering with different neural network architectures using Keras. Downside, it is very difficult to scale to large production projects simply because the high levelness of Keras makes it harder to debug sometimes, and it also means that it's harder to customize things within Keras. The last deep learning framework we're going to talk about is PyTorch. So PyTorch is developed by Facebook on top of this other deep learning framework called Torch. Torch is written in Lua, which is not a very well-known language unlike Python or Java. And so porting Torch into PyTorch means that a lot more developers have access to the power of Torch. Much like TensorFlow, PyTorch supports dynamic computation graphs, meaning you can define how matrices gets passed through a neural network architecture, and computations happen as the matrices travel through a computation graph. PyTorch's design decisions means that the code that you write when you're using PyTorch is more Pythonic, which leads to cleaner code, although sometimes it means that you are writing more boilerplate code. It has better performance than TensorFlow when we look at benchmarks, which is a big plus. And in terms of implementation choices, it is simpler than TensorFlow. There's usually only one way to define a network, which means that a lot of developers are now favoring PyTorch over TensorFlow. So enough with this very high level comparison and feature description of the three frameworks. Now I'm going to show you how each of the framework allows you to define some convolutional neural networks, and we can have a deeper and more meaningful and more practical comparison. Let's first look at Keras. Keras is very familiar to us because that's what we have been using throughout this course. Just to reiterate here, in Keras, when we define a model, we first create a sequential constructor, which creates a sequential model that allows us to add layers. As you can see in this example, we're adding a few convolutional 2D layers onto the model in the first few lines. And we basically define 2 blocks of convolutional layers and a block of dense and dropout layers. We then compile this model, and we can immediately go on to fit, train, and evaluate this model with a scikit-learn-like interface. Contrast this with TensorFlow. TensorFlow is obviously more complicated than Keras. First of all, it operates on matrices and doesn't have as defined of a concept of a model. So as you can see here, the input layer is a tensor produced by TensorFlow's reshape function, reshaping the features x into a 4D tensor. It then passes this tensor through the first convolutional layer, tf.layers.conv2d, and you can see that in this convolutional layer, it has a more complicated definition when you compare this implementation versus the Keras one. As you can see, each of the subsequent layers are also defined with slightly more code, and so it gives you a higher level of control, but you then trade off the ease of implementation of this CNN. You would then look at how a PyTorch CNN is defined. We can see that the code is very clean. Evidently, there is a lot of implementation detail that is hidden from us. A lot of the cleanliness comes from the fact that PyTorch code conventionally doesn't have a lot of parameter values in the constructors. So as you can see, conv2d 365 obviously denotes things like stride and kernel size, but then this is implicitly noted, so you have to understand what comes first in a convolutional layer when we define this in PyTorch. The other difference is each PyTorch neural network is defined as a class, and every time a computation happens, the forward function is called, as you can see here in class net, and that's slightly more Pythonic than how TensorFlow is defined, and that gives us cleaner code, although there's a little bit more boilerplate. The benefit of this is because there's only one way to define how a neural network works in PyTorch. What happens is you'll have more boilerplate code, but it's easier to find where the network code is. To train and define loss functions for PyTorch neural network, you can see that on the right hand side, we have a very similar syntax as compared to Keras. We've just learned how TensorFlow, Keras, and PyTorch differ amongst deep learning frameworks, and I encourage you to go explore the documentation and examples of each of these frameworks individually and learn which one that you like the most.